Hello everyone, welcome to this webinar on deep dive into Anthos multi-cloud capabilities. My name is Janaki Ram. I am an analyst, architect, and an advisor for startups based out of Hyderabad, India. It's my pleasure to bring you this exciting topic where I'm going to walk you through a variety of capabilities that Google has introduced through Anthos. If you're attending this webinar series for the first time, let me set the context. So MI2 stands for Machine Intelligence and Modern Infrastructure. Currently, we are experiencing a convergence of two technologies. One is Kubernetes-driven modern infrastructure and AI-driven machine intelligence. And these two are going to be the future of enterprise IT. So every month, I bring one of the sessions from these tracks. This track is obviously the infrastructure track, where I'm going to walk you through Anthos. But the next topic that I'm going to cover is going to be on Onyx, which is Open Neural Network Exchange. So every alternate webinar chooses from one of these tracks. So I've been running this for about 2 years now, and I have seen a lot of success, particularly in terms of attendance and the feedback. So I'm really excited and even privileged to bring you these cutting edge technologies. So without further ado, let me get started. But before that, a very quick poll. So let me make sure that you're able to listen to my audio and okay, perfect. So looks like everyone is able to follow me well. So that's pretty good. So it's time for us to get started. So let me set the agenda. So Anthos is very confusing. Google took a while to basically launch it, but the documentation, the messaging, and what you read on the web is not complete. So I'm going to set the stage, give you the prelude of the current state of Kubernetes and why Google has launched Anthos. And then we will get into the details of Anthos architecture. And then I have pretty extensive demos where I'm actually going to show you how we can bring Amazon EKS clusters into Anthos fold and how we manage them from Anthos. Then I'm going to show you a demo of GitOps, where we will deploy applications across multiple clusters via Anthos. And then finally, I'm going to show you how we can use GCP Marketplace to deploy applications irrespective of where the clusters are running. This is true multi-cloud, where we use GCP Marketplace to push an application all the way to AWS into an EKS cluster. So this is a special edition because unlike my typical webinars that last for about 45 minutes, this will go way beyond an hour, but trust me, it's worthwhile. And I'm going to walk you through the complete architecture and live demos, which will drive the point across. So let's get started. We're going to have a fun ride. So this is Kubernetes. Most of us are familiar. At a very high level, there is a control plane in the form of master. Then there are multiple nodes that are connected to the master, and the control plane essentially takes care of the scheduling and controlling the deployments, exposing the API, and basically coordinating the distributed computing aspect of Kubernetes. Initially, Kubernetes was new and it was not mainstream. It was confined to very niche use cases, very niche developers, and it was not an enterprise platform. It was basically used by a lot of open source enthusiasts and a lot of developers and DevOps engineers that really like the architecture. But very quickly, like wildfire, it caught up a lot of attention. And today, a lot of enterprises are considering Kubernetes, and it is becoming the new Linux of distributed computing. Now, with that, there is a set of challenges. Now, if you remember a decade ago, when VMware popularized virtualization and started pushing ESXi and vSphere, there was a concern that there was VM sprawl. Somewhere in mid 2000, VMs have become too tough to handle because every developer, every IT admin, and anyone who had access to a vCenter console went ahead and launched a virtual machine. And that led to what was called as VM sprawl, and it became unmanageable. and it was very fragmented. There was absolutely no control on how the images were managed and how the VMs were managed, the life cycle, and so on. And eventually, VMware built a lot of tools to bring that into control. Now, what is interesting is today we are experiencing something very similar, and I call it as cluster sprawl. Now, spinning up a Kubernetes cluster is no more a difficult task. You have a lot of tools. For example, you can use kops to spin up a cluster on AWS. You can push a button on GCP console to launch a GKE cluster. Then there is AKS. Then there are tools like Cube Spray. And of course, there are mini cubes and kind and whatnot. So today, similar to what VMware has seen with VM sprawl, Kubernetes is experiencing a cluster sprawl. Now, instead of creating a new namespace and a role binding associated with the namespace, a lot of developers and DevOps and SREs are actually preferring to spin up a cluster because of the ease of spinning up and also the isolation it provides. But what it actually leads to is a lot of overhead. When the enterprise IT is at the center of this, they are exactly facing the issue that the VMware admins faced a decade ago: cluster sprawl. There are so many clusters, there are privileged pods, there are security holes, there are no best practices followed, and there is no visibility. Anyone who has access to a cloud account, anyone who has access to virtualized infrastructure are spinning up a new Kubernetes cluster, and this is becoming extremely fragmented, and we are losing control. Now, it is spanning multiple environments. It is not just the data center. In a typical environment, for example, the dev test could be running in data center, the UAT cluster could be running in Azure, staging is running in AWS, and production is running in GCP for a variety of reasons. Now, within the enterprise, there could be multiple clusters per department. Now, I'm not exaggerating, but this is the reality. Finance, HR, legal, IT, ops, all of them have a variety of clusters of different sizes, shapes, and colors running all over: on-prem, cloud, colo, virtualized, bare metal. And this is becoming a big trouble because we don't have a meta control plane to basically control the cluster sprawl and get a single pane of glass to manage all these clusters. Now, imagine we build a layer on top of the Kubernetes master, something like this. Now, all the Kubernetes masters technically roll up into the meta control plane, and it is doing what a Kubernetes control plane does, but instead of managing the worker nodes, it is actually managing a set of clusters. So just like a node, a deployment, a controller is managed by Kubernetes control plane, the entire cluster's lifecycle, health, and a variety of stages and states are maintained and managed by the meta control plane. Now, once we introduce the meta control plane and enforce a mechanism that any cluster running within the enterprise has to be a part of the meta control plane, then the central IT will get a lot of benefits. For example, cluster lifecycle management becomes very easy. Now you ask meta control plane to spin up a new cluster, and this new cluster is completely hardened and based on the enterprise IT spec. So it is not deviating from what is expected. And then it's also easy for you to set consistent deployments. Imagine you need to run something across all the clusters. Today, you got to run kubectl 20 times if you're managing 20 clusters. But with meta control plane, you push the deployment to the control plane, the meta control plane, and it will eventually find its way to pretty much every server registered with the meta control plane. Same thing with configuration and policies. With Kubernetes 1.18, the pod security policies are now available, of course, in beta. So you can actually register a lot of policies that will bring in a lot of hardened security aspects to the cluster. So you can actually submit all those policies to the meta control plane, and it will own the policy enforcement. And of course, observability. This is big because we want all the clusters, even if they are running Prometheus and Grafana within the cluster, we need to have a unified dashboard to actually double click and check the health of every cluster registered with the meta control plane. And finally, Kubernetes has a very aggressive cadence of upgrades. Every year we see 2 releases, and sometimes the enterprise has to really catch up and roll out the newer version, because there could be new features that are required, or there could be patches that need to be applied. So maintenance becomes easy because you have a single control plane that can federate and delegate to all the registered clusters. Now, this is the direction in which the industry is moving. There are a lot of examples of this. For example, of course, Anthos, I'm coming to that, but Azure Arc does something very similar. Rancher was one of the first to envisage this problem and build something like the meta control plane. Then Tanzu from VMware, Tanzu Mission Control is pretty much the meta control plane. Then we have Red Hat's Advanced Cluster Manager, which does this. So this is becoming critical for the success of Kubernetes in enterprise. Now, what is Anthos? Well, pretty straightforward. Anthos is Google's meta control plane for Kubernetes. It is basically the layer above the master, above the Kubernetes control plane, to take take control of all the registered clusters. And it is not just about managing a bunch of clusters, but Google has optimized this essentially for hybrid and multi-cloud environments. Now, I'm going to expand further on that, but this is not a plain vanilla control plane that can tackle a bunch of clusters, but this is essentially built on the principles of true hybrid cloud and multi-cloud. Now, one of the first multi-cloud platforms to be announced in the industry is Anthos. Then some of the ones that I mentioned followed the bandwagon. So they jumped the bandwagon of the multi-cluster control plane. Anthos is Google's key enterprise offering. It is very special for Google because this is the first time that they're actually shipping something that is on-prem and will directly target the enterprise segment. Till now, Google has been a pure play cloud platform. They didn't have any foot at the door. They didn't have anything to be deployed in the data center. But this is the first time that Google will actually ship something that will directly get into the enterprise data center. It supports both VMs and Kubernetes clusters. The idea is to basically make Anthos the unified control plane, not just to orchestrate clusters, but also VMs. Eventually, you'll actually see Anthos orchestrating the lifecycle of VMs, and it already supports migrating VMs to containers through Velostrate, which is Anthos Migrate, and it can also take existing VMs and turn them into GCE instances. So that is basically the control plane that Google has built, and obviously GKE, the rock solid and the best Kubernetes implementation in the public cloud, is powering Anthos, which is GKE, Google Kubernetes Engine. Now, when I said Anthos is built for multi-cloud and hybrid cloud, what I meant was Google doesn't highlight this, but the fact is, if you like GKE, and I personally like GKE because it's one of the very, very stable, reliable, performant managed Kubernetes clusters in the market. And if you like GKE, imagine getting the same reliability, same stability, same security, same hardened cluster, not just in the context of GCP, but in your own data center, in AWS, and even in Azure. This is technically Google bringing its GKE cluster or the platform, the managed platform, to competing clouds like AWS and Azure, and also to on-prem. Now, just like you use G-Cloud to basically create G-Cloud container cluster, and you can create a cluster, you can actually create a cluster via Anthos, but instead of provisioning that cluster in GCP, it will provision that in on-prem or AWS or Azure. And this is very, very powerful. But what if I don't want to spin up clusters via Anthos, but I already have a set of clusters? You can register them, but they become unmanaged. The life cycle is not managed by Anthos, but the previous ones that I mentioned, where Google really brought GKE to other environments, there the entire life cycle is owned by Anthos, and that is the key difference. But technically, you can onboard any cluster that is running in any environment into the context of Anthos. Now, to drill down further, how are the components layered, and how do you visualize Anthos? Well, let's take the uh, bottoms up approach. Basically what powers Anthos? Well, it is Kubernetes, but it is Anthos GKE. It is the same GKE version, but Google has been improvising GKE to support the use cases of Anthos. So let's call that as Anthos GKE. And I have a feeling that at some point Google will actually rebrand GKE as Anthos, because the line is completely getting blurred. So it is Anthos or GKE, but based on Kubernetes. Then there is config management, where you can deploy applications, policies, and configuration to all the registered clusters from one single source of truth, which is your Git repo. So that is config management. And Google has built a tool called config sync. It's not open source, but it is available for any platform. That means you can actually use config sync without using Anthos. So what powers config management is config sync. And then the service mesh, and this is super critical for Anthos, because all the network policies based on Envoy proxy is managed by Istio. So behind the scenes, Anthos service mesh is powered by Istio, and the hybrid version and the commercial version of Istio has become Anthos service mesh. But this is going to enable a lot of interesting use cases where you can actually put the traffic director or the HTTPS load balancer at the front end, and then route the traffic across multiple federated clusters, and they will find their way to the appropriate service based on Istio's traffic routing and traffic policies. So this is combined with ingress controller and eventually traffic director. It will become very powerful routing and traffic management and observability platform. Cloud Run is the Google's clusterless serverless platform, and it is powered by Knative. So Knative is the platform, Cloud Run is a developer experience, and Knative is built on top of Istio. So Cloud Run makes it extremely simple to bring a container and quickly get a URL out of that. So that is Cloud Run, the developer experience part. And finally, you need an endpoint to route the traffic, and that is Ingress, which is nothing but Google's global HTTPS load balancer responsible for routing the traffic. Now, the best way to visualize is this. So you have Kubernetes at the bottom, Istio, config sync, Knative, and Ingress. Now you can replace these project names with Anthos commercial labels, like Istio is Anthos service mesh, config sync is Anthos config management, Knative is completely hidden, it is Cloud Run, and Ingress is Google's HTTPS load balancer. So that is how Anthos is layered. The foundation is firmly built into Kubernetes. Now, where can I really run the Anthos clusters? And mind you, when I say Anthos clusters, I mean managed clusters that come with the same SLA and SLO of GKE. Now, the entire life cycle of these clusters are managed by Anthos. You can spin up an Anthos GKE cluster in GCP, no brainer. It is Google's home turf. They have a lot of flexibility. So GCP is the most preferred platform to spin up a Anthos cluster. Then on-prem, you need vSphere 6.5 and vCenter to launch GKE within the enterprise data center. And AWS, this was launched last month, the first week of May, and it has become generally available, which means on AWS, you can actually run a GKE managed cluster. And very soon, it is going to be extended to Azure. As on date, Azure is not available, but very soon, GKE becomes available on Azure. Now, the other way of visualizing this is Anthos control plane orchestrating the cluster lifecycle, and the clusters can run anywhere. Anthos on GKE, Anthos on vSphere, Anthos on AWS, Anthos on Azure. Now, each of them are fully blown, fully fledged clusters, and these clusters have a heartbeat to Anthos. They report their current state to Anthos. Now, once you have provisioned the infrastructure and used Anthos to basically launch clusters, the entire life cycle, now all the way from launching a cluster to upgrading and maintaining and managing and monitoring, all of that comes via Anthos. So you don't have to deal with individual clusters. So they are very similar to the experience of launching a GKE cluster on GCP. So let's call them as managed clusters because they enjoy the same HA and same availability as GKE. So the way it works, again, drilling down further, if we take a look at how Anthos does that in vSphere, basically Anthos needs three things: compute, storage, and network. Now on vSphere, the ESXi or the vSphere is the compute, which is the hypervisor. vSAN or the vSphere data store becomes the storage. F5 big IP becomes the network. And Google has its own overlay network, and you can actually use Calico or any overlay network like Cilium or any other CNI compliant network within the cluster. But the ingress and load balancer equivalent typically shows up through the F5 load balancer, or Google also supports what is called as a bundled load balancer, which is a software defined load balancer called Seesaw. If you don't want to use F5 big IP, you can actually use Seesaw, but that is the network. vSAN or the vSphere data store is the storage, and vSphere and VMs are the worker nodes, and basically they provide the compute. So the way it works is you basically launch a user cluster, sorry, the cluster master in vSphere. So before that, the moment you deploy Anthos in the data center, Anthos will launch its own cluster, and that cluster is actually called as the admin cluster master, and that is the meta control plane. Now, this meta control plane has APIs to spin additional clusters. So this admin cluster master is the proxy. Technically, it's a proxy for Anthos sitting in the vSphere environment, and it exposes APIs to launch a new cluster. Now, there is only one admin cluster master. It is deployed in HA mode, and via the admin cluster, you launch user clusters, and user clusters will have, again, its own set of masters and worker nodes, and on top of that you run the workload. But what is very important to understand is there is an admin cluster responsible for creating and managing the life cycle of user clusters, and technically the admin cluster is managed by the centralized Anthos control plane running in GCP. So there is Anthos at the GCP side, and then there is an Anthos proxy running in the vSphere environment, and that is called the admin cluster. Now, you can imagine how this will translate to AWS. Now, in AWS, again, Google exploits some of the building blocks of AWS. Instead of GCE, it is Amazon EC2. Instead of GCE persistent disks, it's Amazon EBS. Instead of virtual network and VPC in GCP, here it is AWS VPC. So once you basically create a new VPC and create a couple of public and private subnets, Google gives you a Terraform template to provision the management cluster. For some reasons, it is called management cluster in AWS, while it is called master cluster or admin cluster in vSphere. So the Terraform template will basically spin up the management cluster, and it puts an HD as the distributed database for maintaining the child cluster states or the user cluster states. So the management cluster that is running in one of the subnets of the VPC becomes the proxy for Anthos running in the context of AWS. And that exposes APIs to spin up user clusters. And every user cluster is HA. So essentially every worker node runs in its own AZ, and it enjoys the same HA capabilities as the regional GKE clusters running within GCP. So you can actually spin up and shut down and terminate multiple clusters by talking to the management cluster, which is exposed via the Anthos control plane. So now looking at the big picture, it all comes together. So you have a set of managed GKE clusters that are owned and maintained by Anthos, and they all technically report into the Anthos control plane. And we also have unmanaged Kubernetes clusters. They are not provisioned by Anthos. They are lurking around in your data center and in other clouds, but you can bring them into the context of Anthos, and let's call them unmanaged Kubernetes cluster. So they all talk to the Anthos control plane, and on top of Anthos control plane, we have the service mesh for observability, for traffic, and for security. Basically to impose MTLS communication across microservices, across the communication channel, to bring in very, very rich, insightful observability, and then to enable secure routing and policy-driven routing of traffic, across the services running in these clusters. And then there is Anthos config management, whose job is to take a YAML or a YAML file or a Helm chart and push it to all the subscribed clusters, irrespective of where they are running. And I have a live demo of this. Stay tuned for that. Then there is Cloud Run, which is the developer experience. You don't need to bother about the cluster. You basically throw a container at it. It comes back with a URL, stateless, serverless, clusterless. And there is Ingress, which is the entry point to the entire environment. So users talk to Anthos. They don't really know that they're talking to Anthos, but they come to Anthos via the Cloud Run or Ingress. DevSecOps, GitOps, and SREs deal with config management and the marketplace apps published by Google. Now, this is the most complete representation of Anthos, and it took me a while to visualize and to improvise this, because Google, for some reason, shies away from putting the logos of AWS and Azure. They don't want to really talk about it, but in reality, it can actually run pretty well. So this is the big picture. Now, it's time for me to switch to a demo. So stay tuned. It is going to be slightly a longer webinar, but by the end of it, you will see all the capabilities of Anthos. So the very first step is to bring 3 clusters into the fold of Anthos. And to save time, I have already registered 2 of them, but one that is running in Amazon EKS is left for the live demo. So let me switch to my terminal. So I use a wonderful tool called kubectx. So it basically brings in multiple kube config into one config, and then you can seamlessly switch between contexts. So I'm using kubectx, and within kubectx, you see that there is an EKS context, there is a GKE context, and there is a metal context. So metal represents my on-prem powerful bare metal cluster, and it's running Kubernetes 1.17 deployed via KubeSpray. So how does it look like? Well, this is my first cluster running on-prem bare metal. This is my test bed. Now I have a GKE cluster. So I'll switch the context to GKE, and let me show you the GKE cluster. So I'm running a 3-node GKE cluster in Mumbai region. So there are, oh, come on, okay. So here is the GKE cluster. And let me switch to EKS context. And EKS cluster is also running in Mumbai. So here we have 3 clusters. Now we are going to manage all these 3 clusters from Anthos. So before we do anything related to configuration and management, we need to register these clusters. Now, except the GKE cluster, the bare metal and EKS are unmanaged. I didn't really provision the management cluster in AWS VPC, and I didn't go through those steps, but I'm saving it for another webinar. It's a very, very lengthy process, and I can't cover that in one webinar. So now we have three clusters. Now let me switch to the Anthos interface. So you notice I have 2 clusters here. The first cluster is, of course, GKE. It is running 3 nodes, Asia, South 1B, and all these features can be enabled. And you have seen them in this slide: Cloud Run, config management, ingress, service mesh, all of them. Then there is a registered cluster. Now let's call this unmanaged in our parlance. It is external. And this is my powerful on-prem cluster, 32 CPUs, 4 nodes, lot of memory. I spent a fortune on building this. I have 2 clusters actually. So this is my bare metal cluster, and it is also registered with Anthos. Now you can actually see the same view in the GKE dashboard. So here is the Kubernetes Engine dashboard, and if you look at the nodes, these are the 3 nodes that are currently there. You can look at the complete configuration, but the important aspect is both the GKE cluster and the bare metal cluster are registered. Now here is my EKS cluster. This is running in South 1, AP South 1, Mumbai, and I have 3 nodes provision. We are going to really exploit this. We are going to do quite a bit of stuff with the EKS cluster via Anthos. So a 3-node cluster lying here. Now our job is to enumerate this cluster here. So by end of my first demo, we'll actually have EKS show up in the Anthos managed clusters as an external cluster, right? Okay, so how do we go about that? Well, let me set the stage. So we have explored the environment, basically 3 clusters. So you have to do quite a bit of groundwork before you can actually start registering, and they are not laborious, they are not very difficult. Basically, Google has this concept of enabling service APIs. So you have to basically enable a bunch of APIs for your GCP account. So Cloud Resource Manager, Anthos, Mesh, telemetry, monitoring, GKE Connect, all these need to be enabled in your GCP account. It takes a minute to basically enable them, but I've already run that. So after that, you need to basically create a service account. A service account is like an IAM role equivalent for GCP. if you're familiar with AWS IAM role, think of the service account like the role, the EC2 instances assume. So similar to that, we have a service account. It is typically used by applications. It doesn't represent a user, but it is a role that is assumed by applications and non-human users. So what we need to do is basically we have to create a service account. So this service account ultimately comes back with a JSON file. So this JSON file, it contains the key. So it is basically the Anthos Hub service. So this is the service account. Even if you watch this video again, you wouldn't be able to use this key because I'm going to delete the entire project. But technically, this token is assumed by our cluster to talk to Anthos. So this is a prerequisite. So we create the service account, and then we use the gcloud command. Gcloud container. Now there is an addition called hub. Register. Even GKE needs to be registered because I haven't launched it via Anthos. So it's technically an external cluster till I register it. After that, it becomes a managed cluster because it is GKE. So I register GKE. I send the cluster name and then the service account that we created in the previous step. Same thing with my bare metal cluster. MI2 demo metal is the label that I'm giving for my on-prem bare metal cluster. Again, I pass the service account file and then impersonate that to register with Anthos. Once this is all done, we'll have this wonderful tool confirming that the clusters are registered. So this currently shows, the metal and GKE clusters are registered. It's the CLI version of the dashboard. All right. So now it's time for us to register the EKS cluster. So how do we go about that? Well, just one command. So take a look at this. Memberships register, the cluster name, it's basically a label. My GCP project, I call it Johnny's Sandbox. Context within the kube config, which is EKS, and pass the kube config because it needs to grab the credentials, and then pass the service account because this cluster will have to assume certain capabilities, and this is how it will talk to Anthos control plane. Now let's run this. So we are going to do two things. So I'm going to split this screen, okay, and I'm going to switch to the EKS cluster and then put the kubectl get namespace under watch. And then I'm going to run, oh, sorry, I need to do some reset, which I missed. Just give me a second. Okay, config management system. I should have done this before the demo because this is something that I want to walk you through. So I don't want to leave this running. So once this is actually deleted, the EKS cluster is in a pristine state. It has no clue it is going to be talking to Anthos. So this contains a bunch of CRDs and some deployments. So okay. So now I'm going to put this so kubectl get ns in watch mode and then run this command. Sorry, I lost the. Okay, so now we are registering the EKS cluster with Anthos. Now, the moment we run this command, you'll actually notice that there is going to be a new namespace created called GKE Connect. And that GKE Connect namespace runs an agent, a deployment that is responsible for talking to the Anthos control plane. So there we go. So GKE Connect namespace showed up, which means, let's take a look at what's inside that. So watch kubectl get pods from the GKE Connect namespace. So there will be just one pod, nothing fancy. Think of this as the agent. It is actually called as a GKE Connect agent. That's it. Now that single command, mind you, one single command shows us EKS cluster in Anthos. There we go. This is EKS showing up with Anthos as an external cluster. But unlike my bare metal cluster, which is showing me the inside view of the cluster, I'm not able to see that with AKS. So for that, we need to do a couple of things. So we need to basically push a role binding. We need to create a cluster level cluster role and a cluster role binding. Then for the specific service account, we need to grab the secret and pass it on to the Anthos to actually gain visibility into the cluster. Now, if you're wondering, we have already used the GKE Hub service account. That doesn't really give us the inside view of the cluster. It is only for the cluster to make outbound connections and talk to Anthos. But if Anthos wants to talk to the cluster with more visibility and more insight, we need to do a few things. So now, this command should actually show us, there we go. So EKS is perfectly running. Now I'm going to show you the node reader. So to enumerate the nodes running in the EKS cluster, we need to create this cluster role. So get, list, and watch. This is a read-only view. So let's go ahead and create this. So this will basically create a role which will give Anthos read-only access to the cluster. Then we'll create a service account called Anthos user. And then, oops, why? Okay. Then we create the cluster role binding, and then the service account, basically that binds the role with the cluster role. So don't bother too much about this. This is basically making sure that Anthos is able to talk back to the cluster. So we are creating a user, we are creating a role, we are creating a role binding, and then we'll grab the secret of this service account, which is available in the namespace of GKE Connect. Now, if you actually look at this, this is the secret name. So we will grab that secret and decode it from base 64. So we get a pretty long string. Now this string is the secret associated with the Anthos user that we just created. Don't bother about it. It is just a step to basically create a very permissive, very restrictive user account, and then grabbing the secret associated with the user account and using that to log into the cluster. That's it. Now we have created a two-way connection between Anthos and the cluster, unmanaged EKS cluster running in AWS. And there we go. Now it is actually showing us the configuration. It is running version 1.14. It is registered, 3-node cluster, 6 CPUs, and all of that. And eventually, I'm assuming Google will give us a checkbox to run these capabilities on the clusters. Currently, it only has a link to the documentation, and you have to run a bunch of commands. But eventually, it will become a checkbox. All right. So that was the first demo. And what did we accomplish? We basically brought a third-party cluster, third-party because it's neither in my on-prem, it is not running in GKE, but it's running in AWS, and we brought it into Anthos. So that was the first demo. All right. Now we have 3 clusters registered with Anthos. What can we do? Well, as I mentioned, with cluster sprawl becoming a big nightmare, we need a mechanism to basically push software, that is Kubernetes deployments, configuration settings, config maps, secrets, RBAC, storage policies, network routing policies, whatnot. Basically, we need to make sure that every cluster always runs the desired state of configuration. Today, it is very hard because you have to use something like kubectx, switch, and then run kubectl apply, or you have to rely on your scripting capabilities of bash. It is very hard. Or there are other techniques, but these are the most common approaches. So what are we going to do with Anthos config management? Well, I'm a big fan of GitOps. So what is GitOps? We have seen this wave of infrastructure as code. Basically, whatever the VM world, the enterprise IT did with VM related stuff, all of that is coming to cloud native, but in a very different form. When CloudFormation was launched, people went gaga because guess what? You could actually version control your infrastructure. You dump the CloudFormation template in your GitHub repo, and you can version control, and CloudFormation will get pushed to AWS, the infrastructure gets provisioned, and then the app shows up from the same repo. So things like CloudFormation, Azure Resource Manager templates, GCP cloud deployment, and of course our favorite Terraform, and more recently Amazon CDK for Kubernetes, and Pulumi. All of these approaches gave us infrastructure as code. But in Kubernetes, it is much more rapid. We don't have the concept of infrastructure as code. It has all become configuration as code because YAML is the lingua franca of Kubernetes. Now, whether you are deploying an app, whether you are setting a configuration, or you are enforcing a policy, all of that is YAML, and YAML is plain text. Now, imagine the workflow, and unlike the traditional VM side of world, where you had to use things like Packer, again from HashiCorp, to bake an AMI and then use Terraform to basically provision that AMI into an EC2 instance, and then use other techniques like Cloud Init and user data to push software into it. We don't have that mess. Here, things are pretty straightforward. And here, everything is just a YAML file And the YAML file is just an extension of an artifact residing in a Quay repo or Amazon ECR or GCP ECR, Google Container Registry. So now we have a pretty good mechanism where the CI/CD is very, very smooth, seamless, and less complex. So the way it works is you commit the code. Now it gets picked up by Jenkins. CI gets done, and then Jenkins will generate a set of images, tags them appropriately, pushes them to JFrog Artifactory or any of the on-prem or private registries, and then Spinnaker, tool like Spinnaker comes in, and then it will create release artifacts from the images sitting in JFrog, and then it basically pushes the YAML files. But this approach can be tweaked further by version controlling the YAML files. So that means as soon as you build the code, you're also updating the YAML files, and your code plus configuration lives in one repo, completely managed, version controlled with the power of Git. So you can roll back, you can roll forward, you can take complete control, and you can also use that as a single source of truth. So that mechanism where multiple clusters will watch for a Git repo and synchronize their state with the designated Git repo is called GitOps. So you don't talk to individual cluster, you talk to the Git repo. And the Git repo, the moment the commit is done, it is monitored and watched by agents running in the clusters. They pick up the code, I mean the commit ID, and they will sync the local repo with the remote repo, and then they will use the internal Kubernetes API to submit the artifacts, and the cluster comes to a new state. And the beauty is, if there is a drift, for example, you imposed a policy that says don't run privileged pods. You cannot run it with host PID is equal to true, security context is privileged. You cannot run that. Now you impose that as a policy, you put it in GitHub, and it propagates itself to all the clusters, and some rogue admin will actually delete that policy to inject a pod with host privileges. Now, the moment that is done, because it is drifting and deviating from the single source of truth, which is Git, the agent running inside the cluster will immediately pull the YAML spec, or rather will check if the YAML spec is up to date, and then immediately applies it. So that means even if the deployment is gone, even if the namespace is gone, it shows up again. And this mechanism is called GitOps. So the way it works is you take your YAML file and you add, push, commit to Git, and then from Git it finds its way to all the registered clusters. Now the keyword is registered clusters. Registered with what? Anthos. So Anthos Configuration Manager is the platform that enables this single entry point to propagate configuration across all the registered clusters. So Anthos Configuration Management will basically point all the clusters to a repo, and then it also pushes an agent into every cluster which will watch for the drift. The moment something is deviated from the source, which is Git, it automatically synchronizes the state. And this is a brilliant mechanism for enterprises to make sure that the cluster state is always at a point where it is the most optimal, secure, hardened, desired state of configuration. Now, this is what is called Anthos Configuration Management, and it is based on GitOps. Again, time for me to show you a quick demo. So let me switch to my second demo. So the way it works is, again, this is basically running a YAML file. So what GCP does is it gives us an operator. So you have to download this operator from a Google Cloud Storage bucket, and then you apply that operator to the local cluster. And once the operator is up and running, then you create a specific configuration management that points the local cluster to the GitHub repo. And then the agent that is deployed with the config management will be securely connected with your GitHub or GitLab or Cloud Repo anything that is using the Git as the version control protocol, it can actually synchronize with that. And then Google also ships a tool called Nomos, which will give us a good mechanism to monitor the state and even generate the scaffolded files and the directory structure required for config management. So how does this work? Well, I have a very simple GitHub repo, and this GitHub repo has a directory called config. And inside config, I just put a placeholder. There is nothing. So this is the repo that I eventually want to use for GitOps via ACM. So now our job is to deploy configuration manager and then point configuration manager on every cluster to this repo. So how do we do that? Well, let's first run the config management operator. So again, let me put the namespace. Okay. Let me put the namespace under watch. And now run this command, which is going to deploy the config management operator. And this config management operator is a set of CRDs and actually not a CRD. There is one CRD, but it is more like a deployment as well. So now that actually creates a new namespace. And under this namespace, there are a bunch of things that are running. So this is actually going to show us that the configuration management operator is up and running. Now this is the agent, or rather the operator that actually does the heavy lifting. Now we can also query the Kubernetes events. Okay, we are actually running a different version of Kubernetes, so we don't see the events. That's fine. Now, how do we link the GitHub repo with our ACM agent? Well, we create a secret, and that secret will hold the private key associated with GitHub. So and you can actually use read only. For example, all you need is just pull, and you never want to modify. You can actually avoid this, and you can simply use the unauthenticated mechanism to pull the files from the repo. But let me actually show you this step. So I'm going to create this secret, and this is coming from my, there are, so there is this private key. I am using that to create a secret, and this secret acts as the secure link between my cluster and the GitHub repo. And then we actually create a config management specifically for the EKS cluster. And how does that look like? Well, this is the config management thing that we are running. So this contains all the critical inputs. So cluster name is mi2 demo EKS. This is the same name that we have used to register our EKS cluster. Now this is the Git repo. This is the actual URL. Branch, I'm using master. Secret type is SSH. If you're not using SSH, you can actually put that as none. Policy directory is config. Now, if you remember, this is the directory where we are going to dump our artifacts. So that's why I put that as config. Unstructured, where you can actually mix and match code with configuration. If it is structured, then Google imposes a hierarchy, basically a directory structure that you need to follow to put your YAML files. For example, all the namespaces go into a namespace directory, then cluster policy is going to clusters directory. So there is a specific schema kind of a definition that Google recommends, and you can use that for a very, very structured, very organized way of maintaining your YAML files. But what if you're not using YAML files and you have a Helm chart? That's when you can actually use unstructured. So unstructured will pretty much pull anything that that shows up in the directory, and it is up to kubectl or the Kubernetes API server to accept or deny. So that means you can even push a shell script, but obviously it's not going to work. But a Helm chart dumped in this config repo will get applied through GitOps. So this is where we're actually registering the agent and setting up a link between our GitHub repo and ACM, Anthos config management. So let's run this command, where we are connecting the dots. So now this is going to inject 3 pods, or actually deploy 3 pods, and those 3 pods are responsible for managing the GitOps. Okay, I think it's still not created. Give me a second. I hope I am on the right cluster context. This is the big risk of doing a live demo. Bear with me while I try to figure out why it is actually not showing up the pods. Okay, I missed a step, and I'm just trying to recall what I would have missed in this process. This is pretty straightforward, but looks like I have missed a crucial step. So let me just pick up my original master script that I used to configure everything. Okay, give me a second. I'm going to basically undo this and then try this again. So there is the namespace, which is basically responsible for the config management. And within that, we should see a bunch of pods responsible for syncing the repo. And what is confusing me is why are the resources not created while it very clearly mentions, okay, it is okay. Okay, so looks like okay, so I actually followed all these steps, but looks like the actual configuration is already in place, and I didn't do a proper job of resetting it, but technically we are actually at the same spot where I wanted it to be. So so the steps involved are exactly this. So basically you deploy the operator, and then you deploy the config management specifically meant for your cluster and the repo, and then you download this utility called nomos. And when I run nomos status, it actually shows that it's all in synced state. Okay, that means things are looking pretty good. And if you are wondering what is this last sync token, it is if you look at the commits, this is basically the same commit in the say GitHub repo that I did. So 8E83 and so on. Okay, all right. So now let's go ahead and actually run the demo, right? Where we will deploy an application and do a commit and see what happens. So here I have a directory called mi2 demo, which is cloned from my GitHub repo, and currently lsconfig shows nothing. We don't have anything. So what I'm going to do is I'm going to deploy a namespace and a pod. So, and they're pretty straightforward. This is the namespace, and we call that as Anthos mi2 demo. And within that namespace, we're going to deploy a busy box. Nothing fancy. But the idea is, how do we deploy this across all the 3 clusters? So let's go ahead and do that. So cp demo ns.yaml to the config directory, and then we do the same thing with the pod. We copy this to config. So now we have modified the state of the repo. So what I'm going to do is, add this and then run git commit, added deployment, okay, and I'm going to do a git push. So when I do a git push, so it is basically writing it to, committing it to GitHub. Now, if we come back and do a refresh, we'll notice that GitHub is in sync. So config directory will show us, two artifacts, the ns and the pod. Perfect. Now, let's keep this in watch. So we have this tool called Nomos. So let's run that. So Nomos status. Now, this tool will give us the current state. So what this will do is basically, okay, it already picked up. So these two have synced, and now this one will change. So, and if the configuration has really gone bad because of my reset and deployment pattern, maybe it's not going to get updated, but let's do one thing. So here, let's switch to the metal context, right? So I have the bare metal cluster, and when we actually do kubectl get ns, there we go. So the Anthos mi2 demo namespace, which is what I defined in my definition, has been created. And I didn't use kubectl apply. I basically pushed it from ACM. Now, what actually happens? Let me show you the same thing. Unfortunately, it's not working with EKS because of the config management agent issue. But never mind. I will show you the same thing with the metal server. So now we are currently watching the bare metal server, and what we'll do is we'll actually remove the files that we have copied last time, right? And then I'm going to repeat the steps. So we'll add this, and then we will commit. So deleted deployment, and then we'll do a git push. Okay. So now the push takes place, and then we will come back and see the no more status. So this will tell us, okay, so now you actually notice that this has changed. That means the commit ID has been synchronized, and then it does the same thing for GKE pretty soon. And you notice that this is now getting terminated. So, this is the advantage of using, there we go. So now GKE is also completely synchronized. For some strange reason, I missed propagating it to EKS, but you get the idea. Now, it doesn't matter how many how many clusters we have registered under Anthos. You can pretty much push this across all the clusters, and that's exactly what is called as the GitOps. So now you get an idea of how this actually works. So you commit to your cloned Git repo, and then the ACM agent will monitor, it will pull the configuration, and it will apply to all the clusters. So that was GitOps with Anthos config management. All right, so now finally, keeping my fingers crossed, we are at the last demo. So how about this? We are going to use the GCP marketplace, and from there we'll actually push a workload, which is PostgreSQL, via Anthos control plane to an EKS cluster, right? So let's actually see how this works. So running Google click to deploy apps in Amazon EKS, it's going to be pretty interesting. And I hope this works because I tested this multiple times. And first, let me set the context to EKS. Okay, so currently we don't have a namespace for PostgreSQL. So we have to do a little bit of plumbing. So what we need to do to get the one-click deploy from GCP to EKS is this. So again, don't worry about how this is actually done. There are some steps, but ultimately we are going to run PostgreSQL. So first thing, I need to create a storage class. Now currently in EKS, we have a storage class based on GP2, and this is the default. But for one-click applications to work, we need a storage class called standard that got to be default. So what I'm going to do is first remove the default flag from GP2, which is the EBS based storage class. Now that is no more the default. Then we'll actually deploy our own storage class, and our storage class, which looks like this, is not very different. It is still based on GP2, but we have changed the name to standard and we turned the default class to true. So we'll go ahead and apply this, which will create a new storage class. So this, okay, I'm in the wrong directory. Okay, so now this creates a new storage class, and when we do kubectl get sc, there we go, standard based on EBS, and it is the default. Perfect. So now we have to create a namespace called application system. So let's go ahead and do that. And then we need to switch to the context of this. So I'm going to run a set of commands. So basically we are going to pull images from Google Container Registry into EKS. So how do we know what password is required to pull those images? So I've already created the service account that is capable, the IAM role equivalent, to pull the images from the marketplace Google Container Registry. That is how we basically associate the EKS cluster with GCR. Otherwise, we cannot pull the images from marketplace into a cluster other than GKE. So then I need to basically patch the image pull secrets, otherwise it will look up the default Docker Hub. Now this command will basically make the namespace use the GCP marketplace instead of the standard Docker Hub. So basically we are manipulating this namespace to pull images from GCP instead of the standard Docker Hub. So we created one namespace. Then I'm going to create another namespace for the workload. Let's call this PGSQL. So I create the PGSQL namespace, and we'll switch to the namespace just to make it easy instead of adding -n and the namespace. And then we're going to, again, for this namespace, let's create a secret to pull the images from Google Container Registry. Let's patch this again to move it from default Docker Hub to GCR, and that's it. So now we basically created two namespaces. Okay, one is called the application system and the other one is called PGSQL. So with this in place, we can actually come to the Google Cloud Marketplace. Okay, here is the marketplace, and search for PostgreSQL Server. So this is an Anthos certified workload. So we are now pushing an app. So you see the Anthos logo, this is certified to run on Anthos. So we'll select this workload, and without using kubectl apply or anything, we'll basically click on configure. Now when we push this button, it is very fascinating to see what happens next. So it shows us all the clusters. So it chooses EKS, or we can even switch to bare metal, but I choose EKS as the target. The namespace that I want to push this app is PGSQL that we created in the previous step, and we already annotated that to pull images from marketplace. And we'll use the default service account. That's it. So so we are now pushing an app, one click, and let's come back to the command prompt. Watch kubectl get pods from PGSQL namespace. So in a there we go. Okay, so now in I'm keeping my fingers crossed. This should really work. It should now deploy PostgreSQL, and given the state that the EKS cluster is in. I'm not sure if this will finally deploy, but okay, looks like it is finally getting through. So while this is happening, let's query the PV and PVC. So I'm going to now look at PVC. So under the, okay, not required. It is up and running. So now Postgres is running inside EKS deployed via the marketplace. Brilliant. Okay, now let's actually test this. So I'm going to set some variables and basically invoke the Postgres client to connect to the PGSQL instance that's running in EKS. So we'll export the password that is used by the one-click deployer. Okay, now keep my fingers crossed. I'm actually trying to connect to the EKS PGSQL instance from my local host, and we should be right in the shell. Phenomenal. This is exactly what I wanted to accomplish. EKS cluster registered with Anthos, GCP marketplace pushing apps all the way to EKS cluster, and from my local machine, I'm connected to that pod. This is true multi-cloud. And this is the first attempt at true multi-cloud initiated by Google, and it can't get better than this. So if you are wondering what really happened, now it all comes up here. So when I do a refresh on the marketplace, everything is green. So the PGSQL deployment is up and running, it's green. Here are the artifacts, the Kubernetes objects that are created, a PVC, a stateful set, a service, a secret, and whatnot. Now, if I go ahead and delete this, let's actually do that. So I'm going to delete this, and let me put the namespace in watch. So when we actually, okay, it already wiped it off. So it's gone. The moment I hit delete, it's gone. Now that's exactly what is multi-cloud. Push workloads, manage configuration, and deal with it across multiple instances. So I see a lot of questions. I'm coming to that. Now let me summarize what we have seen so far. So we did three things. First, we brought 3 clusters into Anthos fold. And then we used Anthos config management to push deployments and policies to all the registered clusters. Then the third thing was leveraging the registration of EKS. We pushed an app all the way from GCP marketplace to an EKS cluster via the GKE connect and the Anthos control plane. So 3 things. All right. So before I get to the questions, let me bring this up. So it's poll time. Did I meet my promise? I called this deep dive when I was a bit concerned, but with all the demos, I was pretty confident that it qualifies to be called as deep dive, and I hope it met your expectations. And it did, because 90% of you said it's highly relevant and it met the expectation. Thank you. One final poll. How was the overall experience? Now this translates to my presentation skills, the demo quality, the whole experience of attending the webinar, including the audio visual element. All right. Thank you so much. I'm glad you found it high quality. Okay, so this is already, as I mentioned, it's a special edition. I went way beyond. It's 1 hour 15 minutes, but given the excitement and given that so many of you stayed back while I went through all the 3 demos, I want to really answer the questions, because you deserve that interaction. So let me see how many I can answer. So okay, by the way, the slides, the entire video will be uploaded. You hit the same URL that you registered, you'll actually find the recording. And I also want to announce one more thing. Now I want to thank our sponsors, Google Cloud, for feeding me with all the infrastructure, the credits, and supporting me with everything that I needed for this. They are actually the premier sponsors for MI2. Newstack, my media sponsor, and I want to share this with you. I am actually running a 4-part deep dive Anthos series at the Newstack starting this weekend, and every aspect that you have seen will be completely documented, will be scripted, and with explanations, with code snippets, and with links to GitHub. You can actually repeat this. So everything that you have seen will get published at the Newstack in the next 1 month. I've already written 3 parts, and I'm waiting to publish it. I want to thank Foghorn, one of my clients, and also an edge computing company based in Bay Area. Portworx, again a client and also a sponsor, a cloud native storage company. So with that, I want to come back to the Q&A. So, all right. So can Meta control plane have HA and DR? Absolutely. So Meta control plane is invisible. If you think the control plane of EKS, AKS, and GKE are HA, Anthos meta control plane is also HA, and it is most critical because it is the master of the masters. So it can't go wrong. It is absolutely HA, and even the deployment that Google does with AWS and VMware, that is in complete HA. Otherwise, Google cannot deliver on the promise of high availability. So how GKE runs in AWS or Azure? Like, how do they allow this? Well, I explained to some extent, but it's a very complex, intricate set of details. But I'm going to do another webinar where I actually deploy GKE in AWS. So stay tuned for that. It's a pretty intensive workflow. So can we apply policy and configuration and observability and Istio to a non-GKE cluster and manage it from Cloud Console? Yes, not sure what you mean by manage from the Cloud Console, but you can actually deploy anything that is legitimately Kubernetes object. You can run it via Anthos. Instead of creating a demo namespace and a pod, you could pretty much populate the repo with Istio artifacts and use that to push Istio. So technically, absolutely possible. All right, I'm going to answer 2 more questions and we are going to wrap it up. A lot of questions on the recorded session and slides. You'll actually get all of that. So by weekend, I'm going to upload, I'm going to share that link with you. If you rename, okay, so this is like a suggestion on what I could have done, but I actually went through, I think some steps that I mixed up. All right, so that actually brings us to the end of it. Looks like there is one final question. So can Anthos service mesh be deployed on non-GKE clusters? Yes, yes, you can, because Anthos service mesh is technically Istio. So it is not extremely clear. Google doesn't explain whether you can mix and match Istio with service mesh, but technically speaking, you should be able to deploy Anthos service mesh on unmanaged clusters and non-GKE clusters. All right, folks, that's all for today's webinar. I'm going to come back to you with my next webinar on Onyx. That's in 2 weeks from now. Thanks again. I hope all of you are safe and maintaining social distance and ensuring that you're all well and safe. So all the slides, all the recordings will be available very soon. Thanks again. And if you liked it, tweet about it, share the recording when it becomes available. And for the next webinar, do sign up and bring your friends. I want to share my understanding of the emerging technologies, and I appreciate your attendance. Thanks once again. Good day, good night, depending on where you are. I'll see you in my next webinar. Thank you.